Kajian Penghasilan Peta Bahaya dan Risiko Cerun Fasa 2 Kawasan Cameron Highlands, Pahang. Cameron Highlands is Malaysia's most extensive hill station and a district in the state of Pahang. It occupies an area of 712.18 square kilometers, about 274.97 square miles. To the north, its boundary touches that of Kelantan. To the west, it shares part of its border with Perak. Cameron Highlands is one of the tourist hotspots in Malaysia, located at the Tiwangsa Range, which is undergoing continuous development and expansion. The landslides at Cameron Highlands are associated with slope failures and landslides that needs to be identified and mapped. The infrastructures at Cameron Highlands are usually damaged due to the human activities and slope instability and are a challenge to accommodate due to the demands of development. The need for the slope hazard and risk assessment is crucial for a safer slope sustainable development. This project duration is 6 months and the study area of 200 square kilometers. The objectives of the study are 1. To prepare slope hazards and risks at Cameron Highlands area, Phase 2. 2. To prepare conceptual proposal and cost estimation of strengthening and remedial for high-risk slopes. 3. To assist government agencies and local authority council in development planning control and sustainable land use. The scope of work for this project will be divided into 2 stages. Stage 1. Landslide and man-made slope inventory map preparation. Stage 2. Hazard and risk map preparation. In order to carry out this study, detailed slope information is required. This data comes from 4 major components of projects. 1. Airborne LiDAR. 2. Field data collection and field verification. 3. Geographic Information System (GIS) analysis. 4. Geotechnical risk assessment. LiDAR stands for Light Detection and Ranging. LiDAR data that has been captured before and is used to generate digital profile of the surrounding terrain in the form of a point cloud. The point cloud was processed and also GIS layer was generating the important factor map for the slope hazard and risk mapping. Base map preparation. Base map preparation is done where slope polygons are overlaid with the GIS layer, which is Digital Terrain Model, DTM, Hillshade, Contour, and Autophoto with 7 cm resolution. The field team can begin the process of slope identification and mapping. The slope is done by looking for closely contour lines. Each slope is manually identified by a geologist and given a slope polygon. Once generated, the slope polygons are ready to verify either it is landslide inventory or man-made slope inventory. In the field, slope polygons are visually verified and the slope information is captured into proforma. Field team will begin the field data collection and ground verification process. Field data collection and field verification. Slope are verified at the field and all information captured via a set of proforma. Primary slope proforma, incident slope proforma, structural slope proforma, geology slope proforma. Potential debris flow was collected at site. Debris flow occurs naturally at streams where side slopes are steep and the catchment is large, especially in hilly terrain. Debris flow is usually triggered by intense and prolonged rainfall, initiated by accumulation of debris which block the stream. Geographical Information System (GIS) is very useful in landslide hazard assessment study. Factor maps are derived to generate the susceptibility and hazard maps that is required to design a system to a ranking, prioritize and mitigate high hazard slope. 13 causal factor maps were used for susceptibility map generating. A landslide susceptibility map subdivides the terrain into zones with differing likelihoods that landslides of a certain type may occur. From the 13 causal factor maps, hazard map is generated with addition of triggering factor, which is rainfall interpolation. Element at risk. The population, building, economic activities and infrastructure in the area are potentially affected by landslide hazards. Different elements at risk carries different consequences and ranking accordingly. Database and GIS integration. The database will be customized in accordance to the requirements that are identified during the study. For example, Integration of the risk database and the hazard database will be developed to produce the hazard and risk maps of the study area. The map preparation from the project are landslide inventory map, man-made slope inventory map, susceptibility map, hazard map, vulnerability map, risk map. Geotechnical risk analysis and conceptual mitigation measures. The information from LiDAR and GIS are used in the design of the mitigation and strengthening works for slopes classified as high risk. There are 11 critical slopes which are in need for mitigation works. The site is located at Jalan Pos Bertau, Lembah Bertam, FT 102, Kilometer 22, nearby TNB Ulu Jelai Hydroelectric Dam. The site is located at Jalan Pos Bertau, Lembah Bertam, FT 102 and Kilometer 15, nearby SK Manson area. The site located at Jalan Pos Bertau, Lembah Bertam, FT 102. The site is situated nearby Lembah Bertam area and surrounded by agriculture area. The site is located at the road to Bo Tea Centre, Habu, close to the Bo Factory and the visitors parking area. The site is located at the Bo Tea Centre, Habu, close to the house building. The site is located at the back of the building of Terisu School, Cameron Highlands. The site is located along Jalan Lojing Pos Blau, FT 185 at Kilometer 61 under the district of Lojing, Kelantan. The pier of the bridge is constructed at the toe of this slope. This project was successfully completed in October 2018. The main deliverable of this project, such as landslide susceptibility, landslide hazard, landslide vulnerability, and landslide risk map, have been established for Cameron Highlands area. Slope inventory, critical slopes, and potential debris flow have also been identified within the study area. At the end of this project, it will guide and assist the government or local authorities for slope monitoring, landslide mitigation and development planning in Cameron Highlands. Thank you.